Completing the square, case number 1. Completing the square is a process that helps us to bring something in standard form into vertex form. How does it go? Well, let's say I have x squared plus 6x. In algebra tiles, we got an x squared tile and 1, 2, 3, 4, 5, 6 x tiles. If I'm asked to make a square with this, or an approximate square, would I put like 2 here and 4 on this side? That doesn't make much of a square. But if I put half and half, so I'm going to put 3 and 3, then that almost makes a square, except there's a hole there. How big is that hole? Well, if I got 3 here and 3 here, this is a 3 by 3, which means that I need to put in 9 of the unit tiles. Let's see if I can fit them in. 3, and another 3, and another 3. Oh yeah, that completes a square. We just filled that square up. How big is this square? Well, this side is x, and this side is 3. This side is x, and this side is 3. So it's an x plus 3 times x plus 3. Oh, it's x plus 3 squared. And that's x squared, 6x's, and 9. So to complete this square, I need to add 9 to this expression. But wait a second. That's true. If I add 9, it completes the square, but it also changes my parabola. If I add 9 to this parabola, it goes up 9. I need to bring this parabola 9 down, which I'm going to do it by doing something that is going to look silly. I'm going to subtract 9. Add 9, subtract 9. Why? Because it doesn't change anything. So what's the advantage? This part right here, when I added the 9, that is that square. So I can replace these 3 terms with just x plus 3 squared. Oh yeah, x plus 3 squared is x squared plus 6x plus 9. And the only thing I haven't used is my minus 9. So I bring that minus 9 here. And what do you notice? We have vertex form already here. So now we could say perhaps that the vertex is minus 3 and minus 9. That is how we complete the square with case number 1. Let me give you one more example. So what if we say that we have y is equal to x squared minus 20x. Okay, I don't want to deal with those algebra tiles because I don't have that many. So I'm going to pretend that I have them. I'm going to draw a square, and I'm going to say my x squared is going to be here, so it's going to be x, and I have 20 x tiles. So I need to put half on top, half on this side. So that's minus 10 and x minus 10, which will make an x minus 10 squared. So if it's 10 by 10, this is going to have a square that's going to have 100 little units. So in order to complete this square, I need to add 100, and just to adjust it so I bring it back from those 100, I take away 100. And we now know that these 3 guys are actually this square right here. So this is x minus 10 squared. And I still need to have that minus 100 from before, which means that my vertex form is x minus 10 squared minus 100. Our vertex would end up being 10 and minus 100. Let's look at case number 2.